Okay, so today we're going to work on adding integers. And as an activator, here are a couple sets of chips, and your job is to write number sentences to see if we can solve these. So we're going to take the first one together. So the first one has 1, 2, 3, 4, 5, 6, 7 negatives, and it has 1, 2, 3, 4, 5 positives. So a couple ways we can write this number sentence. We could write negative 7 plus 5. Or we can switch the order and do 5 plus negative 7. Or really what that also means is 5 minus 7. All three of these are equivalent to each other. Each one of them, even though they're written slightly different, is saying there's 7 negatives and 5 positives. So the key to solving these is we're going to form zero pairs because every one positive and one negative cancel each other out. So when I look at this first group here, I see that there are more negatives, so my answer is going to be a negative. To see what my actual answer is, I'm going to line them up because now I can form zero pairs. So remember, the original problem here was negative 7 plus 5. We're going to see what that's actually worth. When I start thinking about this, every one negative and one positive cancel out because 1 minus 1 is 0. So here's 1 minus 1, those cancel out because that's 0. Those cancel, those cancel, those cancel, those cancel. And what we're left over with is 2 negatives. So negative 7 plus 5 is negative 2, which makes sense because there's 2 more negatives than there are positives. There's a slightly trickier one. In this case, what we have here is we have 5 negatives, and we're combining that with another 3 negatives. But when I think about this, in my first problem, I had a mix of negative and positive chips. I'll go ahead and erase these just for a second. I had a mix of negative and positive chips, which is why we were able to cancel them out and form these zero pairs. But here, there's nothing to cancel. They're all negatives. So when I combine these together, I have 5 negatives here and 3 negatives here for a total of 8 negatives. So when something is the same sign, this is what you've really been doing since kindergarten. Like if I had 3 positives, 2 positives, that would be positive 3 plus positive 2, which is positive 5. There's nothing to cancel out, all positives. There's nothing to cancel out in the middle row, all negatives. When there's things to cancel, that's when you form the zero pairs. So we'll show these using integer chips again, just as a quick refresher for everybody. So, and they actually have the answers with them, just so you can see kind of how it works. So negative 2 plus 6 means there's 2 negative chips and 6 positive chips. 1, 2, 3, 4, 5, 6. So when I take a look at this, I have 2 negatives and 2 positives that are going to form zero pairs. They're going to cancel each other out. These will cancel and these will cancel. And what you're left over with are 4 positives. The second example where it says positive 3 plus negative 5. Well, the reason the answer is a negative number is because there are more negatives than there are positives. There's 3 positives here, and there's 1, 2, 3, 4, 5 negatives. So as these cancel out, what's remaining is just the 2 negatives. The last one, we're starting with 4 positives, and a problem like this shows really why it's important to draw these out. Minus 8, so 8 negatives. 1, 2, 3, 4. 5, 6, 7, 8, and you'll see that all of these will cancel out and you're left with 4 negatives. So on this page are 3 examples. Go ahead and pause the tape and give them a try. Once we go over these, go back to the blend space. Okay, first one, 4 positives. 1, 2, 3, 4, 6 negatives. 1, 2, 3, 4, 5, 6. 0, 0, 0, 0. 2 negatives left over. Negative 2. The second problem, I see 3 positives and 8 negatives. So I'm just going to talk through this one instead of drawing the chips. Well, I know there's more negatives there because there's 8 negatives. Well, if there's 3 positives, that means 3 of those negatives will cancel out and we'll be left with 5 negatives. And the last one, 2 negative chips, 3 negative chips, 5 negative chips.